Okay, so we are doing the next problem, which is find the winner of the circular game. What is this thing? Okay, so we're gonna start with problem decomposition. So, n friends sitting in a circle, numbered 1 to n, okay, clockwise. Okay, moving clockwise from I, so from I to I plus 1 for 1 that I that n. So I guess this is more of a definition, right, of clockwise. And then I equals n 2, 1 for n. Okay. So what are the rules here? So rules. Okay. 1, start at first friend. Okay. Count next k friends clockwise, including the friend you started at. Okay. Starting point. Counting wraps around the circle and may count some friends more than once. Okay. Last friend counted leaves circle and loses. Okay. Keep looping. Clockwise of the friend who just lost and repeat. Okay, so given okay, so this seems to make sense. Let us go through an example. Can we see? Maybe kind of. Okay. So let's say n equals 5, k equals 2. What does that mean? So here's 1, 2, 3, 4, 5, and they're all in a circle. Okay. And I mean, let's see here. So let's run through the example. So basically I start here, right? And I go, so start a friend 1, count 2 friends clockwise. So go 1, 2. Try friends 1 and 2. Got it. So I go k minus 1 every loop. Okay, so that's where we get that rule. And then, so then we eliminate 2. So that goes away. Hold on. Okay, so yeah, basically there's a decision I have to make, which is how do I handle deletions, right? And so there's a few methods of doing so. So either I can maintain a I don't know, visited set, right? And so basically I'll use that to skip over. I'll skip over. That's number 1. That's going to take, the space complexity is going to be O of n, right? O of n. That's one thing. Number 2 is I can remove, like actually remove entry from a data structure. But if this is in some sort of array, right, then the operation is removal every time is O of n. So that's not so good. Oh, but anyway, I'm going to need O of n space, right? I'm going to need O of n space to, so need O, is this O of n space anyways. And then another thing I just thought of now is I can represent in a linked list, right? Where removal is literally just, so removal is a pointer change, right? Or removal is a pointer pointer update. So the time is O of 1 really to do the update, and then we'll just have a special links list called a circly, I think it's called circly links list, where it's that, and then all you have to do is you just keep iterating until you get there. So what would the time complexity, I think this seems to make sense. So what would the time complexity be of this? So let's see. So traversing k elements, so every iteration we're going to be traversing k elements, and we're going to be doing this up to n times. And then the space, I mean, is going to be O of n, right? Can we do better than this? I mean, simulating is going to be this, right? So simulation is going to be k times n. N being the number of removals, n minus 1 really, but to n. Okay. So I think that's what we're going to do. Seems to make sense. Fair enough. Let's switch over. And this will be fun. So const node, or get node is gonna be, and I like to use arrow functions for everything. So what I'm gonna pass in is the value, which is a number, and then I could do a next node, which is let's say type node, is equal to value, which is a number, and next, which is a node. Okay, so get node is going to be a node, and the next is going to be potentially a node, right? So I'm going to be returning, I have to return a node, so this is going to be the value, right? And the next pointer, so next is going to be equal to next or null. Okay, nice. So now this is just a get node. Okay, so now that I have the node data structure, it's going to be comprised of a few steps. One is construct circle linked list. That's number one. Number two is run or write algo for performing removal. And number three is loop until only one element. Okay, and I think that's it. So constructing the circle linked list. So basically, let head, let dummy is equal to get node, right? And this is going to be -1. Fine. So I have this dummy. Why do I want the dummy? So for let I equals 0, let's do 1. No, let's do 0. I like to. I is less than n. I plus plus, right? So for every one of these, what am I going to do? I'm going to create node. So const new node is going to be get node, and the value is going to be I plus 1. And cool. Now I'm going to say let cur is equal, or let tail is equal to, I'm going to start it off at dummy, and I'm going to say tail dot next is going to be equal to new node, right? And then tail is equal to tail dot next. Okay. And then I think we're good here. Okay. So what we're doing is we just generated this. And then at the very end, connect back, connect tail to head. So how do I do that? I'm just going to say tail is dot next is equal to tail dot next is equal to dummy dot next. So what I've done here is I've just connected the tail to the head. So now what I have is dummy dot next is the start of the circly linked list, which is great. This is what I want. Okay. And so now that's step 1. Now step 2 is, and what am I at time? Step 2 is write the algo for performing the removal. So basically, how do I do that? I need to iterate over k. I guess it's k minus iterate. No, not iterate. I need to advance the pointer by k minus 1. To advance the pointer by k minus 1 times and perform the removal. So what's interesting is if I want to, so let's go back. Oh, good, okay. So let's go back here, and something interesting is happening. So let's take this case again, which is 1, 2, 3, 4, and 5. Okay, so let's say I'm at 1 and I have to remove the second value, right? So what I'm gonna need to do is okay, if k is 2, I'm gonna be removing the second element, so I'm really iterating k minus 1. So in this case, actually, I don't need to, my current is here, right? And so if my current is here, I really don't know if you can see it, yeah. If my current is here, I'm not gonna want, how many times to advance cur? And so how many times to advance cur if k equals 2 is actually none, right? Because so k minus 1, so I want to advance, so I want to delete the k minus 1th next element, right? But in order to do that, which is I'm deleting this one too, but in order to delete 2, I need to be referencing the next pointer of 1. So really, so traverse k minus 2 places. So number 1 is traverse k minus 2 places. In this case, I'm not actually removing anything. I mean, I'm not moving anything if k is 2. So that's number 1. Now number 2 is rearrange pointer to delete 2, right? So that's gonna be just node.next is node.next.next, right? And in this case, and then number 3 is advance cur by 1, okay? And that seems to be the strategy. So given a node, let's say const handle turn, right, where we're gonna be taking in a current node. Okay, so we're taking in a current node. So handling a turn is number 1, traverse k minus 2 elements. Number 2 is delete next element. And number 3 is advance cur by 1. So maybe what I can do is I'm going to be returning the next node. So I'm going to be calling this head, even though it's not the head. So current node. Okay, but let iter node, let's call it. Let's start that at current node. And I'm going to be let I equals 0. Oh, sorry. What am I doing? 4. Let I equals 0. I less than, also I need k, which is a number. K minus 2. I plus. Iter node is equal to iter node dot next. Okay, so that's traversing k elements. So now iter node dot next is equal to iter node dot next dot next. That's deleting the element. Then advance cur by 1. So return the new head, which is going to be iter node dot next. Yep. Okay. And so now that's handling the turn. So I'm going to be doing, at every iteration, so I can loop until only one element, or I know the closed form solution of, or how many times I'm doing a removal, right? So in this case of n equals 5, so let I is equal to 0, I less than n minus 1, I believe, I plus plus, so let cur node is equal to, going to be starting at dummy.next. Okay, so that's the head, right? Because I'm starting at the head. What I'm going to do is cur node is equal to handle turn, where I'm passing in the current node and k. So I'm just going to be returning cur node. .val. Look at that. So in the case where k is 1, interesting. Okay. We're almost there. And what is our time? 24 minutes, great. So 1, 2, 3, 4, 5, 6, 2, that. Yeah, there's some sort of, so, and then if k is equal to 1, what should happen? Okay. So basically handle turn, right? What should handle turn do? So what this is doing here is it's not actually iterating. So k is 2. So this is not actually, so if my current is here, or iter node, okay. So I'm not actually traversing anything. Then I'm deleting the next element. In this case, am I having to delete myself? Yeah, I have to delete myself. So in order to delete myself, so in order to delete myself, what I have to do is I have to iterate. I have to go all the way back. I have to wind all the way back to previous. Or what I can do is make this a doubly linked list, which increases the space increases the space. It's not any more complex. It's just multiplying the space by 2, which asymptotically is the same thing. And then I can do this in O of 1 time. Or I can just have a case where I just keep looping until I get here. So if k is equal to 1, I'm gonna do something else. I'm gonna be doing this. Okay, so what happens if k is equal to 1? I have to traverse until I get behind me. Okay, so basically it's very easy, which is while true. And what I'm gonna do in the true statement is if iter node let if iter node dot val is equal to okay, so basically I have to iterate until my iter node's next is equal to myself. And I think this should work. Yeah. Nice. Okay. So let's look at the solution. See, similarly with the list, start by representing using list data structure. Yeah, but how do you remove the friend? So that's times complexity. There's a pop though. You can use a Q. Interesting. The Q. How? Simulate the process by rotating the Q K minus 1 times. Move the next K. Oh. Fine. Yeah, that's basically what I'm doing. Yeah, okay, so this goes to n by k, which makes sense in the space. And I guess there's recursion. How many approaches are there? Eliminating the kth friend from a circle, shrinking the size of the circle at every turn. This suggests that we can break down the problem into smaller problems. I guess so, yeah. It's like a smaller instance where this is the situation. We'll track both the number and index of each friend in the circle. Okay, so the state of the recursion is both the number, track both the number and the index of the friend. Got it, yeah. Zero base, okay, yeah. First round, we start our counter. Oh no. Iterative. But optimize it by eliminating the excess space with recursion. So you can do O of 1 time. What is this? You are eliminating the kth friend from a circle. Okay. Let's look at a smaller instance of the problem where n is 4. Okay. Okay, so you track both the number and index. Okay, yeah. Because the index is going to change over time. And just one base, okay. We start to count at friend 0, eliminate her kth friend. Okay, with k equals 2, we eliminate friend 1 at index 1. We need 3 friends in the circle. We treat the friend immediately after friend 1 as a new starting point. The updated index looks like that. This process, there's 2 key insights. The problem initially dealing with a circle of n friends now reduces to n minus 1 friends, yeah. A new subproblem, I think this is important. Friend indices shift by minus k. So for instance, friend 3 moves from index 3 to index 1 in the new circle. Got it. Okay.